Welcome back to the Calculus Prep assignment. This is math from the void. Triangles coming at you out of nowhere. And today we're going to continue with some geometric applications with algebraic techniques. So here you can see we have this five-sided shape, almost like a house, where we have ABD as a rectangle, BCD is an equilateral triangle. We talked about this. If we have an equilateral triangle, it is also an equiangular triangle. All side lengths are the same, and all the angles are the same. Let's call the side lengths x. There's x. There's another x. And that is also x. Keep in mind that if this is a rectangle, this side must also be length x. They give us some conditions. The perimeter of this entire shape is 33. So I'm actually going to remove this for now, just so you don't get confused. This does not contribute to the perimeter. The perimeter is only the outside. So that would be the following. This segment, and this segment, with two remaining segments, AB and ED. So what's the goal of the problem? If the entire thing adds up to 33 inches, find the number of inches in the length of AE that maximizes the area. So we want to maximize the total area. So first we need to get an expression for the total area. Let's take a look at what shapes we're dealing with here. So we want this area, which is the area of an equilateral triangle. We know how to do that. In the previous part 17 video, we took a look at that. And we also have this rectangle area. So we need a way to describe these areas. How about rectangle? Wow, kind of wonky. Like a slice of bread. Rectangle plus equilateral triangle. Okay, in the equilateral triangle, we already did. This is going to give us root 3 over 4 x squared. If you need to go back and check that video out, feel free. What about the rectangle area here? So I see that one of the dimensions is x. That would be like the side AE. But what about these two sides? How much are these? Well, those two are equivalent. If the entirety is going to be 33, then we could take 33 and subtract the 3x from these sides. And then we can divide by 2 because there are two sides, which are in blue. Now, this might not look very pleasant, but it's okay. We can work with it. And if we want the area, it's simply going to be length times width, or base times height for the rectangle. So we can write this as x times 33 minus 3x over 2. We want to find when this is a maximum. So we need to work this out just a little bit to turn this into a more standard looking quadratic equation. Let's remove the 1/2 here. I'm going to take that out. And I'm going to put the x in. So this gives me 1/2. You know what? There's no use in taking the 1/2 out. Let's just multiply the x in. I'm going to write the x squared term first. So we're going to have negative 3 over 2x squared plus 33 over 2x. And then we're adding this other x squared term, which is going to combine as a like term. However, we need the same denominator. So I'm going to modify this fraction by multiplying 2 over 2. And so now we have root 3 minus 6 all over 4 x squared plus 33 over 2x. This is our total area, and we want to maximize this. Hopefully you recognize this again. This is a quadratic equation. And we want to find a maximum. We've done this process a couple of times, so you should be familiar with this. Give yourself the opportunity to try it. I also want you to verify that this is going to give us a maximum and not a minimum, because this coefficient right here, this is negative. How do I know it's negative? Let's look at it. On top, we have root 3, which is not even the value of 2, it's smaller than 2, minus 6. So definitely this top portion gives us a negative, and divided by 4, that kind of shrinks it down a little bit, but it's still a negative. So that means that the area could be represented by a sort of upside down quadratic, which will have a maximum at some point. Okay, let's do the steps. You know the steps. The steps are going to be a little bit less nice in this case. I think we just need to find the value of x, though. Yeah, find the length of AE, which is the value of x. So we don't have to find what the maximum is. So maybe I should go back a little bit. We just need to find out where the maximum occurs. So we don't need to necessarily find the maximum. We just need to find the x value at which this occurs. And this would be the axis of symmetry equation. X equals negative b over 2a. We just have to be a little careful about how we write this because we have some fractions. Negative b over 2 times this fraction. Okay, so first things first. That cancels to a 2. And then if we flip the fraction, in order to divide a fraction, we flip it and multiply. So this is going to be times 2 over root 3 minus 6. And therefore this is going to be negative 33 over root 3 minus 6. That may seem like it's a negative value, which would not make sense if x were a negative value, right? Because this is a side length. A side length cannot be negative, but don't worry, it is positive. Because this down here, as I stated earlier, is negative. So if we want, we can sort of like factor the negative out, and we'll get 33 over 6 minus grad 3. You don't need to rationalize this. You could plug it into a calculator if you'd like. This is going to be something like 33 over 6 minus, I believe it's something like 1.732. So this would be along the lines of 33 over 4.268. And this would be very close to 8, but not quite 8. Let's say 7.9. Okay, and let's check what that actually is with the calculator. We might as well. Okay, I was quite a bit off. This is about 7.73. 7.732. So if I'm going to round to one decimal place, I want to make sure that it's reasonably accurate. This is better. Therefore, if we have this side length of 7.732, that means this is 7.732, and this is 7.732, and this side also, but since it's not really in the perimeter, I'm not going to write it there, 7.732. And it only leaves, how much does that leave? That only leaves about 10-ish or so inches for the remaining. So this is like something close to 5. Not that they asked, but this is close to 5. I'll just put 5-ish. And this is also 5-ish. Okay, that was a great, simple application of this problem. I know it looks complicated, but in the void we're making things very simple. The key in this problem is being able to represent the area desired accurately. They want us to maximize this area, so you need to recognize two things. You need to recognize that this area is made up of two shapes, a composite, and they're each going to have their own formulas. However, you also need to realize that because this is an equilateral triangle, its side length here, which we can call x on all the side lengths, is the same for this side as this other side because it's a rectangle, taking into consideration our limitation on the overall perimeter of 33 inches. That allows us to solve our problem. If I asked you what the maximum area is, perhaps you can do that as a bonus exercise. I want you to try this without a calculator. It'll take some work, it'll take a lot of writing, but if you can step up to this challenge, you're going to find your future math classes a lot easier. That wraps up part 18 of this Calc prep assignment. Until next time.